Hello guys, welcome back. Today's topic is the breadth-first search algorithm. Uh, my name is Krika Kumari. Let's move to the video. These are the topics. Today we are going to talk about the uh, breadth-first search tree. What is the breadth-first search? The breadth-first search is the traversal algorithm. It is the graph. It is the search technique. And there are two types of traversal algorithm, depth first search and breadth first search. But today we are going to talk about the breadth first search algorithm. These algorithms begin with the root node, that is the source node. We must be go for all the nodes in the graph to complete the algorithm. You should explore all the nodes. It is level by level. Once complete the one level, then we move to the second level. After the completing the second level, we move to the third level. Likewise, we must be complete all the levels, and we access these levels horizontally. Firstly, go for the one level and we access that level horizontally and move to the second level. Likewise, we must be access all the nodes in the graph to complete the algorithm. The traverse of the best first search algorithm is approaching node into the two ways. When we are traversing in this graph, there we can identify the two types of node, visited node and unvisited node. These are all the information about the breadth-first search. Now we move to the how the work breadth-first search algorithm. This is the implementation of the breadth-first search algorithm. I told you every graph must be begin with the root node. Here we get the node A as the root node. Let it mark as the visited and it inserted into the queue. Here we use the queue data structure to store the node which we visited node. What is the queue data structure? Queue data structure is the linear sequential data structure that we can store the data sequentially and access the linearly. The queue data structure use the first in first out order. In the here we insert the node A into the queue and check the adjacent node for the node A. You can see that there are two adjacent nodes S and B. Now we move to this node. Before move to this node, we must be pop up the node A and we must insert the S and B node into the queue instead of the node A. When we are inserting the many nodes into the queue, we must follow the alphabetical order. There is alphabets, therefore we must follow the alphabet order to insert the node into the queue. But if there is a numbers instead of the alphabet in the graph, we must follow the ascending node descending order to insert the values into the queue. But here there is the alphabets, therefore we must follow the alphabetical order. According to the alphabetical order, we can insert firstly B and secondly S. But before inserting the B and S node into the queue, we must pop up the node A from the queue and we must insert the B and S node instead of the node B. Now this is the level 1. This is the level 1. Now we move to the level 2. In the level 2, we traverse in level 2 horizontally Firstly, we access the node B according to the alphabetical order and check whether are there any adjacent node for the node B. We can see that there is any node for the adjacent to the B. Then we pop up the B and check the S. Are there any adjacent node to the S? Yes, there is a two adjacent node we are not visited, G and C. Now pop up the S from the Q and insert the C and G into the Q. Likewise, we must be traverse all the nodes in the graph. Now we move to the node C. Check there is are there any adjacent node? You can see that there is a T node. We are not going move to the we are not moving F, E, and D. These three nodes must be inserted into the Q instead of the C. C is pop up from the Q and get as output and must be added D, E, and F. Now check now we are not going to the adjacent node of the C. Now we go to the G. Check are there any adjacent node to the G? There is two nodes, H and F. But here, F is already visited node. When we are visiting to when we are checking the adjacent node, we must consider that node either visited or not visited. In that here, we can identify that there is a two node, H is not visited and F is the already visited node. Therefore, F is not going to add into the queue because F is already in the queue. Therefore, only we add the H into the queue. Before the adding the H, we must be G pop up from the queue. Now we move to the final, before the next level, check the D. Are there any adjacent node to the D? Therefore, there is no any adjacent node to the D and it is pop up from the graph and check the E. Check whether are there any adjacent node to the E? There is no any adjacent node to the C, E, and F. There is no any adjacent node to the F. And now move to the H. Are there any adjacent node to the H? Yes, there is a node E, but we are already visited node E. Therefore, we are not going to get the answer node. And pop up the H into this is the output of this graph. This is the breadth-first search implementation. I think that you can get the idea about how the work with the breadth-first search algorithm. Now we move to the next slide. Let's discuss the applications of the breadth-first search algorithm. Here you can see that there are many applications related to the BFS. The first one is the shortest path algorithm. It is trying to reach the minimum vertices of the graph using the breadth-first search algorithm. A peer-to-peer network, the GPS navigation system, it is used to find in the locations that we want to use in the breadth-first search algorithm and in the garbage collection. These are some of the applications related to the breadth-first search algorithm. Now I move to the next slide. It is the code implementation of the breadth-first search. Now we look how the code will be executed in the. We discussed how the breadth-first search works. Then now we are going to discuss the code implementation of the breadth-first search algorithm. Here we use the Python programming languages to code the graph. At the beginning of this code, we must import some libraries related to the our algorithm, and after that, here we initialize the graph. Inside of the graph, there are all the elements in the algorithm. After that, here you can see that there is a function declaration. The function name is the BFS. Inside of the parenthesis, there are two parameters, graph and node. If we go back to the inside of the function, here you can see that there is the many statement. The first statement is used to declare the array in the Python. The array name is the visited. After that, here we create the object. Object name is the queue by using the dequeue constructor. Here we create a dequeue object, but its name is the queue. Visited.append. The meaning of that statement is we add the element into the visited array as well as queue object. This is the while loop. Inside of the while loop, the queue is until the queue is empty. This loop will be executed. Inside of the while loop, here you can see that there s is equal to the queue.popleft. Popleft is the inbuilt function. It is used to remove the items from the queue. If we want to remove the sum of the items from the queue, we can use the popleft function. The removed item is assigned to the s variable and prints the removed item on the screen. After that, you can see that there is a for loop. Here we use the for loop to check the adjacent node of the current working node. If the current working node is A, then we want to check the adjacent node to the current node. Here you can see that there is a two adjacent node S and B. We can check the S and B in using this for loop. And inside of the for loop, if n is not in visited is the array name. If the n alphabet is not in the visited array, then condition is true and go to the inside of the if statement, and that not visited element is added to the visited array as well queue. This is the execution of this function. Now here you can see that there is another function. The function name is main. Inside of the parentheses, there is no any parameters. It is going to void. And inside of the function, here we call the BFS function using the argument, two arguments, graph, and A is the root node. After that function we call the main function. The execution of this program is beginning at the main function call. The main function, when we are calling the main function, Python find where the main function in this program. Now go to this location and go to the inside of the main function. Inside of the main function, there is a BFS function calling. Now Python interpreter find where the BFS function in this program. If there is no any functions like s, then Python create the error. Then Python can find the BFS function. BFS function is here and execute the function, and program is end. This is the execution of the program. Let's run the program and look what will be the output of this program. Here you can see the output of the program. This output and here we discussed output must be same. I think that you can get the idea about the breadth-first search algorithm. You can understood something from this video. You can subscribe and like the video. Thank you so much for the joining with us.